This is Sarah Wilkinson from the University of Guelph Humber and Humber College. This video is going to cover how the partial pressure of oxygen changes around the body. In a previous video, I've covered what is partial pressure and how does adding humidity in the conducting zone of the lungs affect the partial pressure of oxygen. I would encourage you to watch these two videos before continuing with this one. In this video, I'm going to show you how the partial pressure of oxygen changes in different blood vessels around the body at sea level. In the previous video, I showed you how at sea level the partial pressure of oxygen is 159 millimeters of mercury at the mouth. So the air we breathe has that amount of oxygen. I also showed you how adding humidity in the conducting zone decreases the partial pressure of oxygen, so that by the time the air reaches the alveoli, the little air sacs of the lungs, the partial pressure of oxygen is 105 millimeters of mercury. This is where we're going to start this video. I'm going to explain how the PO2 of 105 in the alveoli affects the partial pressure of oxygen in the blood surrounding the alveoli and how it's transported out to the tissues. So let's start in the alveoli. We're going to look at a single alveolus. I'm going to draw it this way. So you can see here, this is a representation of an alveolus. And we know the partial pressure of oxygen is 105. Surrounding each alveolus is several capillaries. These capillaries transport blood. So within the blood are red blood cells, and those red blood cells contain hemoglobin. Hemoglobin is going to bind to oxygen. Blood arriving at the lung capillaries is deoxygenated, has little oxygen within it. Through gas exchange with the alveoli, the blood leaving the capillaries will be oxygenated. Let's trace a single red blood cell as it enters the pulmonary capillary and receives oxygen from the alveoli. We're going to represent oxygen in this example with green dots. So we're going to see how oxygen diffuses from the alveoli into the capillary. We know that the partial pressure at rest in the pulmonary arteries is about 40 millimeters of mercury. So that is how much oxygen is contained within the blood arriving at the lungs. And we know that oxygen diffuses from an area of high pressure to an area of low pressure. We're going to see that oxygen leaves the alveoli and moves down its pressure gradient into the tissue capillary because of this difference in partial pressures. So as the red blood cell enters the capillary, oxygen is going to move into the blood. It's then going to enter the red blood cell and attach to hemoglobin. As the red blood cell moves through the tissue capillary, more and more and more oxygen is added to it until it becomes saturated and reaches equilibrium with the alveoli, so that the blood leaving the pulmonary capillary is about 105 millimeters of mercury, which is the same as the alveoli, and we call that equilibrium. Now, not all alveoli obtain sufficient amount of blood flow to reach this equilibrium, so that the overall average PO2 in the pulmonary veins leaving the lungs is about 100, because some of the blood is well oxygenated while other parts of the blood isn't. As a quick recap, the pulmonary arteries delivering blood to the lungs have a PO2 of 40 at rest at sea level, and as the red blood cells transit through the alveoli, there's a movement of oxygen from areas of high pressure to areas of lower pressure until equilibrium is almost met, so that the blood within the pulmonary veins, so the blood leaving the lungs, has a PO2 of about 100 millimeters of mercury. This is obviously going to change if we go to high altitude, which I will do another video on. The blood in the pulmonary veins is returned to the left side of the heart, and the left side of the heart pumps the blood out through the systemic arteries, so that the PO2 in the pulmonary veins is always the same as the PO2 in the systemic arteries. That blood is delivered to the tissues, and within the tissues there's going to be a particular partial pressure of oxygen. So in the muscle cell at rest, PO2 is around 40 millimeters of mercury. Again, we're going to be setting up a partial pressure gradient between the capillaries and the cells, so that the blood entering has a PO2 of 100, and the blood exiting will have a PO2 of about 40. So again, oxygen travels down its partial pressure gradient from an area of high pressure to an area of low pressure, until the blood becomes equilibrated with the cell, so that the blood leaving the systemic veins has a PO2 of about 40. This blood returns back to the right side of the heart and is pumped back out to the pulmonary arteries, and this whole transit of the red blood cells begins anew. Now, let's spend a little time looking at the partial pressure of oxygen within the cell. We use the example of a partial pressure of oxygen at rest in the muscle tissue being about 40 millimeters of mercury. However, when ATP production goes up, for example during exercise, there's going to be a greater demand of oxygen and therefore a greater use of oxygen. So during intense exercise, so say for example maximal exercise, the partial pressure of oxygen within the cells, within the tissues, goes down, because as soon as it enters, it is used by the mitochondria to accept electrons and becomes water. So now let's look at an example. The partial pressure of oxygen being delivered by the systemic arteries during exercise is mostly going to be about the same, 100 millimeters of mercury. However, now within the tissues, the partial pressure is 15. So this sets up a larger partial pressure gradient. So there will be a greater movement of oxygen into the cells because of this large partial pressure gradient. Just like at rest, the capillary reaches equilibrium with the cell so that the partial pressure of oxygen leaving is the same as is in the cell, 15 millimeters of mercury. That's pumped back to the heart, and the pulmonary arteries will have the same partial pressure of oxygen. So now, again, we have a larger partial pressure gradient in the lungs, being that 105 versus 15 is a much bigger number than 105 versus 40. So more oxygen will move down its partial pressure gradient into the capillaries and then be pumped back out into the pulmonary veins. I hope this video has helped you understand how the partial pressure of oxygen can change around the body, both at rest and during conditions where there's a greater demand for oxygen. In a future video, we'll look at how the partial pressure of oxygen can be affected by altitude or lung disease so that less oxygen is available to the tissues.